This video is on exercise 1D, questions 3 and 4 of A-Level Further Maths Core 1 textbook. In question 3, we should write each of the complex numbers in the form a plus bi. And this is probably one of the most useful techniques that you learn in this chapter, and you are going to use this throughout your study of A-Level Further Maths. Now, first we need to understand what does it mean to write each of these complex numbers in the form a plus bi. So that simply means that you should do some sort of basically operations such that you will get rid of the complex, the imaginary part of the denominator. So that's the goal. And this is very similar to the technique that you learned in GCSEs, which was rationalizing the denominator, because in that case, if you have something like, let's say, a plus square root of b, then you multiply top and bottom by basically the same number, but the conjugate of that, which is a minus root b, a minus root b. And this is exactly the same here. So whenever you have an imaginary number in your denominator, basically you should multiply top and bottom by the complex conjugate of the denominator. That's simply the rule that we are going to follow here. For example, in question 3a, which is this, all you need to do is multiplying the numerator and denominator by 1 minus 3i, 4 minus 3i, and that's it. So the rest is just the matter of working out this, because this allows us to get rid of the imaginary part of the denominator, because we don't want to have imaginary number in our denominator. So we always try to get rid of that. Now the rest, hopefully you're familiar with the rest. Now so 3 times 1 is 3, then 3 times minus 3i is minus 9i, minus 5i times 1 is minus 5i, and minus 5i times 3i is 15i squared. But we know that i squared is minus 1, so this gives us minus 15. And then in denominator we have 1 minus 3i plus 3i. Again, we get minus 9. 3i times minus 3i is minus 9i squared, but that gives us positive 9. And now we can simplify this. So 3 minus 15 is minus 12. Minus 9 minus 5 is minus 14i. And 1 plus 9 is 10. Then minus 3i plus 3i is 0. Of course, you can simplify this and divide each of these numbers by 2, but it's not necessary here. And this is basically the method that we should learn in order to get rid of the imaginary part of each of the imaginary part of a denominator. And we are just going to do this for the rest of the video. So for b, we should multiply top and bottom by 6 plus 8i. Yeah, and now here we have 18 plus 24i, then 30i, and then we get 40i squared, which is minus 40. And then here in denominator we get 36 plus 48i minus 48i, and then minus 64 squared, minus 64i squared, which gives us plus 64. And now we can just simplify this. So 18 minus 40, which is minus 22. 24i plus 30i is 54i. Now in denominator we have 36 plus 64, which is 100. And this is the final answer. So in this one, we multiply top and bottom by 1 plus I. So we get 28 plus 28I minus 3I. Then minus 3I squared, which is plus 3. And in denominator, we have 1 plus I minus I squared, which is just 1. Because I squared is minus 1, but minus I squared is 1. Minus 1, which is 1. And now simplify. So 28 plus 3, that's what we have, which is 31. And then we have 28 minus 3i, which is 25i. And we get 2 in the denominator. And that's it. And finally part D. So we multiply top and bottom by 1 minus 4i. So we get 2 minus 8i plus I. Now minus 4i squared, which is 4. Then we have 1 minus 4i plus 4i minus 16i squared, which is 16. And so 2 plus 4 is 6. Then minus 7i. In denominator, we have 17. Okay, so that's it for the first question. Now let's do the second one, which is question number 4. So question 4 is just basically, the same thing as question 3, but we just need to do more calculation, because in the numerator we have 3 minus 4i squared. But it's fine. So we start by multiplying top and bottom by 1 minus I. Then we get 3 minus 4i squared times 1 minus I. And then in denominator, we have 1 minus I minus I squared. So minus I squared is 1. Again, just to remind you, I squared is minus 1, but minus I squared is minus 1, which is 1. Okay, so let's now expand the numerator, the expanded brackets in numerator. So we have here just better to write 3 minus 4i times 3 minus 4i. Okay, so we have 9 minus 12i plus 16i squared, which is minus 16, times 1 minus I, and then in the denominator we just have 2. Okay, so let's simplify that. Minus 9 minus 24i minus 16 times 1 minus I divided by 2, and we need to expand this. So we have 9 minus 9i minus 24i. So we get 24i squared, which is minus 24. Then we have minus 16 and 16i divided by 2. 9 minus 24 minus 16 is minus 31. Now we can, so we have this. Now we should do minus 9 minus 24 plus 16, which is minus 17 I. So minus 17 I, sorry, I forgot to mention the imaginary part, divided by 2. Okay, so that's it for this video, and I hope this helps. So make sure to like this video and subscribe to my channel, so you can watch my future videos. Good luck.